into the through wall flashing. Okay? Water cannot hang out of the back of that cavity. So typically we draw it that way, and then again in this meeting, we call it attention to, I find out who the sheet metal guy is going to be. I said, you understand what we're looking for here? We want that flashing to have a slope. Can you do that? Oh, you've never done it that way before. Well, you're going to do it that way this time. Okay? Yeah, it was.
Do you have suggestions on the different types of through wall flashing, getting the mortar to bond with that flashing so you don't have that mortar joint cracking out?
That's inherent in the design.
Yeah.
The only thing you can do is try to hold the membrane back. Okay? The Brick Institute is good either way. It's because basically what's happening is the wall is acting as a whole in compression and tension. Okay? So you have all the compression holding the brick in place vertically, but you have the wall ties and tension holding the wall in place horizontally. So this is really inconsequential to how the wall reacts. And if you were worried about that, you know, honestly, I wouldn't worry about it, because if it cracks at this point, that just helps the water get out. I'll probably get shot for saying that, but that's the truth. I mean, your water's going to wick out right here. And even if it doesn't make it to the weep, it's still going to try to go through the mud joint. Okay? Does that answer your question?
Yeah.
Okay. Anybody have any questions on that?
So that piece of flashing right there on down where you lapped it, put it together, how did you put it together?
The two pieces of metal?
That piece of flashing running down that brick wall, how did you lap that
Here?
together? Huh?
They're overlapped with each other over 2 beads of sealant.
Glue.
Right. And then the membrane goes over the top of that. So when the beads of sealant go away, because of the heat cold transfer, then you have the membrane to overcome that.
Or if you've got that water hanging out back there because you left it backwards, that water's traveling down that wall trying to find a way out. It's either going to go to a hole or to a lap if you don't have it.
That's correct. So the membrane helps stop that. And here's a condition where it was not detailed on the drawing, and that's the way they were going to leave it. They told me they were just going to put sealant in that big hole and call her a day. Okay? Well, one of the things that I try to point out to these guys when they're installing this stuff is,
We've all seen that.
Yeah, that's all.
again, you go back to, okay, they flanged it out on the wall, but we needed a counter flashing to go up and over that, right? Well, what we use is a thermoplastic boot in coordination with that, meaning a flexible membrane that kind of looks like this. Okay? It's all hot air welded out of membrane. Thermoplastic sheet. You take that piece and you set it right there, and then you put all the pieces together. So no matter how far apart these get, you still got to back up underneath all that metal to push the water away from that joint. Okay?
So they go underneath the metal? Well, I mean, I guess on the horizontal part,
It goes-
and then the
yeah, it
other part goes on the wall.
Under here and into the cavity, up against the cavity, and then everything goes over that. So your roof, you know, if this was done correctly, I would have gotten rid of this flashing or moved it down here to where it ties into that one, so that they're both at the same level and they overlap. And then I would have covered this block with something. I mean, why would you leave one row of absorptive material that there is on that job wide open to the elements? Well, there's a through wall flashing in there. Okay, so we're getting water in here and getting it right back out here. That doesn't make any sense. Let's just make it where water can't get in the wall at all. Rack.
That's what we got. We got like, we'll have 10 inches, 12 inches of wall panel. Well, why? Why not just carry your roof?
Right. Okay. And then there's an example of how that flashing is installed from start to finish, where parapets abut the rise walls. You guys see the benefit in that? See how the roofing membrane turns the corner and there's a vertical flashing there? Okay? That's called a watertight condition. That's what I try to tell the roofer, the sheet metal guy. That's an example of a watertight condition, if you don't know what that is. Okay? Okay, vertical flashing membrane. This is where we're talking about going over the control joints in the block, or dissimilar materials. You can tell this building has a lot of different materials on it, so we were utilizing that flashing in all those conditions. Window and door flashings. This is where we start talking about installing the windows, flashing them, and water testing them before the veneer. Okay, everything has to be done in shingle fashion. You have a sill flashing with end dams. That goes on first. And in this particular case, what we're designing now, how many times does a window glazer tell you guys that I don't need a subseal, I've already got an integral subseal in my frame? Manufacturer doesn't require me to have a subseal. You all hear that before? Okay, so my answer to that is, I may understand that's the case, but we're trying to build a watertight building, so we're adding a little bit more to it. If we built the buildings according to the code, and only the code, all our buildings would be substandard rental property, right? Because what is the building code? Minimum standard. Do you guys want to be caught building a building of minimal standards? No? No. Okay, good. It's good to know. All right, so we want our subs thinking the same thing. Yeah, I understand it may have an integral subseal in it, but we want another one, and here's why. One of the things that I try to get the subs to understand is the reasoning behind the decision. If they understand the reason, then they're more apt to buy into the why and not argue about it, okay?
The pieces of membrane that are already made up, where do you purchase that?
The freeform pieces?
Freeform.
They come in different manufacturers. You know, you have to decide which one you're going to use, that's why the specification that we provide the architects is physical properties driven. It doesn't list names of manufacturers. That way we open it up to several different companies. Some companies provide the membrane with the membrane freeform pieces. Some companies provide the membrane with stainless steel freeform pieces, because the way they do their mold makes the membrane too thick and it impedes the joints. Like the double coated copper, you know, they have copper that's coated with asphalt both sides. They have freeform pieces. They just don't tell you they do, but they're stainless steel, so that there's no galvanic action between the two materials of galvanized to copper. Okay, so they use stainless steel. They're thinner. You can get them in several places. Okay, now I'm going to show you an example of how we install the windows piece by piece. This is when they put the through-wall flashing in. Notice one of the things they didn't do is, in this particular case, this needs to come on over, okay, past the window. Because when you put flashings on the wall, how do you do it? Trick question. Where's Rick?
Nails?
No. You do it in single fashion. You start from the bottom, right?
Yep.
Start at the bottom, work your way up. Why do we do that?
Well, water doesn't go in.
No backlaps. That's right. Now here's where they installed the subseal before they put the window in. It has end dams. There's the frame. Can everybody see that? There's the backer plate, so the membrane does that. Right? Actually, it goes on down to there, and then that goes down into that. There'll be a preformed piece that's sitting right here. Everybody see that? So you have your preformed piece, your jam flashing comes down inside that preformed piece, and now everything is watertight. Okay?
Now, as opposed to the preformed pieces, I understand, obviously, that would be preferred, but can you make some of those same conditions utilizing the same flashing material and bonding them together, or is that going to degrade so much faster?
Yeah, it's the quality of the workmanship won't be there to make it act the same way. I can show you another picture earlier on in the presentation. I didn't point it out, but
Too much chance for error.
yeah, yeah. They tried to do that in one condition because they just didn't want to buy the pieces, and so they used a lot of mastic, bitumen mastic, and it looked like somebody threw up hydrocide on the wall. Okay, and there was all kinds of little laps and bubbles and everything they did because you can't constantly get it solid. So the workmanship has got to be perfect for it to be the same. Okay. The other thing that we ask is, typically in the drawings and specifications, this is the top of the window. You guys know that the tops of those vertical molds are all open, right? They come that way. That's the way they're built. So we make them put a plate on the top of that frame. So to close that hole off, so that when the membrane comes across, there's not a little gap of where water can just roll right inside the frame. Then we're screwed. We've done all this flashing for nothing. Okay? Another way that they do it is let's say in this particular case, this guy wanted to hang his frames with clips from the head because the window's so far out. Well, this is fine. We can leave this part of the window open because our membrane actually makes contact with that much of the frame. You have to make sure you have at least 1 inch of surface contact between the membrane and the surface you're adhering to. Okay? That's going to be required by all the manufacturers. And then, of course, putting the caps over those openings. Well, there's an example. This is the high school that we did when it came that big rain. That's what the building looked like when that 12 inches of rain was dropped. Okay? Not one leak in the building. And they're actually even cleaning the walls over that shrink wrap. So they lost one window in this building, and it was because the brick mason dropped the mortarboard. And then you can see how you work your flashings around the curved windows too. Those are usually the most challenging, trying to do them around arched windows, because you have to segment the flashings and then counter flash that. Okay. Here's an example of how we do the clear story flashings where the window's above the roof. And these are all shown in isometric and talked about as being soldered pieces. Okay, this is done by your sheet metal guy. And then when you're finished, it looks like that.
That's what we did up around those windows at the rotunda.
Yes, sir.
You found,
Yes, sir.
welded those pieces together like that.
That's correct, right, Bill?
Yes.
That's correct.
Okay. That's what if you can see that, this shows how everything stops at one angle, or one level, right at the bottom of the windows. So it's all clean, clear roofing underneath it, okay? And here where we have, the windows were installed, flashed, and then they sealed the edges of the flashing before they came back and put the damp proofing on the wall. And here's another example of how that flashing is integrated into the plaster and the windowsill at the same time. Not sure how, okay. This is an example of this AMA test. It's a really highly sophisticated project using extremely highly technologically advanced materials. This guy bought this at Home Depot and built it himself. Okay. Basically what you do is you spray 30 psi water on the frame, working your way across the frame a foot at a time every 5 minutes. And once you're finished, if the test shows up to be at least a quarter tablespoon of water or more, then the test fails on the frame. Okay? So you have to go back and check it.
Only 30 PSI?
18 inches away, 30 psi. Because you're not going to get a rain that's much harder than that unless it's a deluge for a few minutes, right?
That's not bad, Angela.
30 psi. You have to cut the water down.
And you're testing that right after you flash the window, is that what you're talking about?
It depends. It's based on your schedule. You know, I've had some contractors wait till all the windows are in and then test them, and I've had them test them as they go. It just depends on how you scaffold up the building, you know, how you're going to get to the second floor, those kind of things. Okay.
And where do you collect the water at?
Oh, you just look on the back side of the frame, and if you see it leaking, then you take a tablespoon, literally, and hold it at the leak, and if it fills up the tablespoon, it fails the test. And you can estimate the amount of water that comes through.
That's in 5 minutes, right?
That's correct. You always start at the bottom and work
You
your
don't
way.
want to have all your windows tested, obviously, before you do drywall on the inside,
Correct.
so you can see it.
Right. See, the whole key to this is if you do this and it works the way we think it does, and what we know it does, you're actually able to finish out the inside of the building and the outside is completely unfinished. You can't.
Would it be advisable to get a couple of windows installed and test them before you do all the rest of the building, just to make sure?
Just to make sure you're installing them properly.
Kind of like a initial
Yeah.
inspection.
I would do that on the mock-up. Okay, you do the water test. Everything you're going to do on the building, you do it on the mock-up.
What's the lights outside on that hydro side?
90 days.
20 days?
Yeah, 90 days. Plus, honestly, the outside work starts going up before then.
I was told there's material out there that's more than that now, 120 days.
And there may be, I'm not privy to it. The problem with my mentality on materials is I like to use something that's more than 10 years old because it's been proven and tested in the field. You know, the new stuff that comes out, because Tyvek has something that's come out, it's only been out 2 years, but they're touting it's better than hydrocycle. Okay, but it hasn't been tested in the field through thermal shock, transfer, heat cold, all that.